Scientists gathered 12 different soil samples from a region to test for ground toxins in the water supply. The amount of ground toxins present in parts ppm, parts per million, are given in the data below. Find the 99% confidence interval for the population mean amount of ground toxins in that area. All right, so this is the result of the different samples. So there's 12 different samples, and this is the amount of ground toxins in parts per million. Now, the first thing we're going to need to do here, since we are doing a confidence interval, and it's going to be a t interval, but since we have data to work with, we have to input that data first. And that data is going to go into L1 here. So I'm going to go under Stat and Edit and start entering the data as I see it here. So 25, 39, 44, and so forth here. So after I get all that data in, I'll go back to the t-interval function and then allow it to come up with the interval for me. But I need to give the data here to start with. Now, when I am doing a t-interval, generally what I need to provide are things like a sample mean, sample standard deviation, sample size. All of that can be determined from the sample data itself. I know that there's 12 values because, I can count 1 through 12. Same thing for the calculator. It can figure out the number of values that are there. It can also figure out the mean. It would just add them all together and divide by 12, and that would give it the mean. Standard deviation. It has a formula to calculate standard deviation. The important thing is it'll save all of those values to as many decimal places as the calculator can hold so that we get the most accurate results in the end. So once that data is into L1, the frequencies, this just means if you were going to enter a frequency distribution where you had one list is your data values, the next list is the frequency of those, you would input your frequency list here, but just put a 1 if that's not present. So that's what we want. Level of confidence is 99%. So we'll just calculate our interval here. And there's our answer. Now, in order to provide the final answer, I need to take care of rounding. Now, normally the rule is round to the same accuracy as the given mean and standard deviation. Well, here we weren't really given the mean and standard deviation. We found those by calculating based off of the data. And generally, when you give a mean and standard deviation as an answer, you're actually going to round to the same accuracy as your data. Sometimes one more value than what's provided. But what we're going to do is we're just going to match the accuracy of the data itself. So for my interval, I'm going to answer mu is somewhere between 13 and 33. So I've rounded each of these values to the nearest whole number.